All right, boys and girls, welcome back to the drive-through. This is your 13.3 lecture, more introduction to trig. Today you'll learn 3 new functions, and you'll learn about what's called a reference angle. So lots of new stuff today. Remember, don't see something that's new and think to yourself that I can't do this. If here's our angle x, then this is our opposite, our adjacent, and our hypotenuse, okay? Let's start with a little bit of a review. What is sine of x? Opposite over hypotenuse, okay? What is cosine of x? I think you're going to want to jot these down on the top of your worksheet, your guided notes, I should say. And tangent of x? Okay, now here's your 3 new ones. I'll write them all out. So the opposite is quite confusing. It's the worst. The opposite of sine is actually cosecant. You guys are going to screw that up. You're going to think it's the opposite of cosine because it sounds like it should be. Okay, so it's called cosecant of x, which is rounded CSC. We'll get to it in the bottom. Hey, cosecant, it's just the reciprocal of sine. It's hypotenuse over opposite. It's quite unnecessary. I've never found a good use for it. Okay? The opposite of cosine is called secant of x. I told you, it's confusing. It's quite a bummer. Secant of x is h over a. And then the opposite of tangent is cotangent. And that's AO. Okay? Just keep that in your back pocket. You'll need that later. Okay, a reference angle. A reference angle is an angle on a unit circle formed by dropping in altitude to the x-axis. You can also think of this as the acute angle. Okay, so a reference angle is always acute. That's something that we're going to want to know. Formed by the radius of the circle and the x-axis. So, 60 degrees. I want you to draw yourself. It's going to look like you're drawing yourself a little sniper target. A little crosshairs. Okay? And then we're just going to follow the directions. So we take the radius, we put it at 60 degrees, and then where do we drop our right triangle to, or our right angle to? Which axis? Always to the x-axis. That thing right there is the angle formed between the radius and the x-axis, the acute angle. The acute angle formed between the radius and the x-axis. So what is that angle? It's 60 degrees. Sometimes things can be so easy that they're confusing. So we'll do another one, and hopefully you'll understand a little bit better what we're doing. Okay? Once again, start with a little unit circle on an XY plane. What quadrant will 135 degrees be in? It will be in the second quadrant. So you draw the angle like you normally would. And then you drop it right down here. This thing right here is the angle formed between the radius and the, sorry, I'll say it again, it's the acute angle formed between the radius okay, this is the acute angle. What's the measure of it? It's 45 degrees, so that's our reference angle. Okay? The angle, the acute angle formed between the radius and the x-axis. It's got to be the acute one. Okay? So 240 degrees. We'll do the same process. Okay? Which quadrant? The third. So here's our initial side. 240. Well, how many more than 180 is that? It's 60 more. That helps me draw a more accurate picture. Draw a perpendicular always to the x-axis. Here's our acute angle formed between the radius and the x-axis. And what's that going to be? That's going to be 60 degrees. Okay? So far, so good? Okay, now it's going to get harder. Why is it harder in the next one? So now we're in radians. Okay? Same deal, though. What I would do is think of 3 pi over 4 as 3 times pi over 4. How many degrees is pi? 180. So what's pi over 4? That's 45. That's a fourth of 180. And 3 times 45 is 135 degrees. You're going to have to get good at changing these in your head. And you'll only have to know the 4s, the 3s, and the 6s, but we'll get to that. Okay? And the 2s. So, where is 135 degrees? Quadrant 2, very good. So it looks like this. And when we drop it, here is our reference angle. So how many degrees is that? But we want our answer in radians. So you do 45 degrees times pi divided by 180. And that gives us pi over 4 for our reference angle. Okay? 7 pi over 6. That's 210 degrees. Okay? Now I'd like for you to know how I got that quickly. I treated that as 7 times pi over 6. And what was pi again? Okay, so what's 180 divided by 6? And 7 times 30? That's how I'm getting that. You're going to have to get decent at doing that in your head. Okay? $210. Which quadrant? Third quadrant. How many degrees past the 180? 30 degrees. So what's my reference angle in degrees? It's 30 degrees. So now I just need to change 30 degrees into radians. Pi over 6. Very good, Henry. You're getting it. So my reference angle is pi over 6. Okay? Now for this one, I am not going to change it into degrees. I'm going to use a different strategy. 25 pi. That's a lot, right? Well, how many pi's is a full rotation? 2, right? So this would be 2 pi, 4 pi, 6 pi, 8 pi. So what else is it? Which one am I going to stop at? No. 24 pi, right? So there's 24 pi's get me right back to where I've started. So then how much more do I have than 24 pi? I've got 1 more pi. So this angle is coterminal with 180 degrees. Do you understand that? It ends up over here. If you think about it, it is rotated 1, 2, 3, 4. How many times again, class? 24 times, no, 12 times, you're right, and then another half times. 12 and a half rotations. Okay? So what is the angle formed between this green terminal ray and the x-axis? 0. Very good. That's our answer. Or 0 radians. 0 degrees is 0 radians. Okay? So I should probably take this degree out because it is in degrees. Are you hanging with me? Okay, good. Not easy stuff. Okay, so now this is pretty recognizable, but now in our right triangle, we're going to act like that point is some point on a circle. This is the point x, comma, y. Where do we drop our right angle towards? To the x-axis. So now, talk to me about the dimensions of this triangle. Here's our right angle. We're going to call this angle, instead of calling it x, from here on out, we're going to call it theta with a th. Can you guys say that? Theta. Okay? What's this side right here? It's x. What's this? This is y. Now, we're not going to call this the square root of x squared plus y squared, but that's how we're going to find it. We're just going to call it r, as in radius. Okay? But I hope you understand this is true. Right? It's got to be true from Pythag. So, what is the sine of theta in terms of x, y, and r? Excellent. It's x over r. Well, that makes the cosecant r over x. You just flip it. Okay? What is the cosine of theta? Sorry, this over here, this thing says y. So cosine will be x over, hold on, we totally messed that up. This should be y. I'm sorry. I was looking at that wrong. Okay? Got it? I'll give you time to erase. I'm very sorry. So cosine is going to be y over r. It's going to be x over r. And secant r over x. And let's see if I can actually get this one right. Tangent should be y over x. And cotangent, x over y. Just stick with me. You're fine. You're doing great to learn this, okay? It'll get easier. Right now, you don't even know what the heck you're learning it for. So I feel for you, okay? Last section of guided notes. Now we consider the point -3, -4. Again, imagine that is on a circle. What's our radius? Very good. It's 5. How did we get that? 3, 4, 5. We did the Pythagorean theorem in our head. But when you write this out now, -3 for this, -4 for that. Is our radius negative? It's not. It's +5. Okay? So, sine will be opposite over hypotenuse. -4/5. Okay? You get that? So cosecant is going to be -5/4. You can put the negative on the top or the bottom. I tend to put it on the top. Cosine will be -3/5. This will be -5/3. Tangent will be -4 over -3, which is +4/3. Do you remember that? A negative divided by a negative is a positive. And cotangent will be 3/4. Okay? Our final challenge. I'm going to have to erase my little picture here. Now you're going to be using your 30, 60, 90 and 45, 45, 90 triangles. So cosine of 150. All you do is sketch a little 150 degree angle, draw its reference angle. This is 150. That's not what we care about. Okay? Our reference angle is 30. Now, this point here, don't you agree that it's negative, comma, positive? Well, now all you got to do is know your special right triangles. So if this is 1, the short leg is 1, what's the hypotenuse? And what's the long leg? Okay, radical 3. Now, do cosine. So shouldn't this be a negative radical 3? Right? So cosine of 150 equals negative radical 3 over 2. See, when it asks you to find the exact value, you cannot use your calculator for that. Does yours come up as negative radical 3 over 2, or does it give you a decimal? That's huge. Nice calculator. So you can use your calculator. Okay? Tangent of pi over 4. What's pi over 4 as degrees? It's 45. This is an easy reference angle because it is 45. What's my 45, 45, 90 triangle simplified? If I call these 1, then what's my hypotenuse? Radical 2. Tangent is? That's right, it's 1. Okay? Secant of 9 pi over 4. Ooh. Pi over 4 is 45 degrees. What's 9 times 45 degrees? Well, let's see. That's going to be 8 times 45 degrees is all the way around the circle, isn't it? So I think this is the same picture. Right? Now let me tell you another way you can do these. If you memorize the things, what's this point right here now that you know that this is 45 degrees? It's the point 1, comma 1. And what's our R? If you memorize these, and they want, what do they want here? Cosecant? They want secant. It's going to be R over X. So if you wanted to do a shortcut, you could say that this is radical 2 over 1. That's the answer. It's R over X. Okay? But that's the same thing that we're doing. There's really no difference. Yes, that's radical 2. I did 9 times 45 and got 405 degrees to get to that angle. Okay? All right, way to stick with me. Tough stuff. Boom!